LaTeX is a mathematical typesetting system used for creating mathematical papers, creating mathematical books, and used by a lot of students for creating their homework for mathematics courses. There are two things I want to say about LaTeX before we actually get started in the details. The first is that this is not a what you see is what you get word processor. You have to produce a source file, which is an ordinary text file and can be produced by any simple word processor. And then the source file is processed by the LaTeX program to produce the mathematical output. So there is a little bit of a learning curve at the beginning when you're starting out in LaTeX. On the other hand, LaTeX produces beautiful mathematical output. The other thing I wanted to say was that probably the best way to learn LaTeX is to look at a source file, one of these text files, and compare it with the output that's produced. And it's usually fairly easy to see what produces what in the source file produces what symbols and various kinds of typesetting in the output file. So here's a quick example of a very simple source file. The first thing you probably notice is that there are these words preceded by a backslash. These are called control sequences. Second thing you may have noticed is that you must have a document class in every LaTeX document. I usually use the article document class, but there are many others. There's a book document class, there's a report document class, and so on. The second thing is the control sequences begin and end are extremely important in LaTeX. There are several examples in this short file. For example, the begin center and end center control sequences begin and end the centering environment. So this is what produces centered text, as you would probably guess. Let's take a look at the output from this source file. The output would look something like this: the word quiz centered at the top of the document, followed by a numbered list of these consisting of these two algebra problems. Why is there so much space between the word quiz and the numbered list? Let's go back to the source file. I use the vskip control sequence, which can be used for inserting vertical space. One other thing you may have noticed is the dollar sign preceding and following the equation. So mathematics is usually typeset in a special environment. The math environment begins and ends with a dollar sign. Okay, so let's look at the details, a few of the details of LaTeX. First of all, getting LaTeX. There are several possibilities. You can install LaTeX on your computer. It's a free program. And this website contains complete instructions and downloadable files for any operating system, the Mac operating system, Windows, or various Linux systems. So getting it on your computer is one possibility. Another possibility, which I recommend if you're just starting out as a LaTeX user, is to work online. You can get a free account at overleaf.com. Here is their website. I have a few instructions here at the bottom of the page for creating your account, but there will be another video where we explore overleaf in a little more detail. So I won't dwell on that at the moment. Two other possibilities. There is a front end for LaTeX called Links. It's a little bit easier to use because you don't have to remember all the control sequences and environment names. But it has some disadvantages. It's a little slower because you have to open menus to get the symbols and the various environments. A second disadvantage is that it's not always possible to import a given LaTeX document into Links. So if you had a LaTeX document you wanted to edit, it might be difficult or impossible to import it into Links. And the fourth possibility is another online possibility. You can use LaTeX from Google Drive, which is available on your eMish account. So here is the basic form of a LaTeX source file. The first line must give you the document class. As I said, article is a frequently used document class, and you can specify the type size. Between the document class and the begin document control sequence, there might be other header information. For example, there are packages that you can use that make it easier and sometimes possible to typeset various kinds of things, like diagrams. And then between the begin document and the end document control sequences is the body of the document. So the sample source file that we looked at earlier followed this pattern. Here's another very simple minimal example. The document class is the first line. I have included two packages here. The AMS symbol package and the AMS math package. AMS is American Mathematical Society. These are two packages that I always use in my LaTeX documents, and I suggest you do the same. Then the begin document, and between that and the end document there isn't much. There is this sentence followed by an equation. So let's look at the finished output for this source file. Here is the text that occurred between the begin document and end document. I see my grammar isn't too good. This is a document contains only one thing. Oh, well. And then the formula, f of x equals x squared. You'll notice that it's on a separate line and it's centered. This is display math. Okay, in the body of a LaTeX source file, between the begin document and the end document, as I mentioned earlier, there will be various kinds of environments that provide special kinds of type settings. For example, the mathematics environment. The math environment begins with a begin math in the braces, and ends with the end math. In between the begin math and the end math, you can enter various kinds of mathematics. If you enter, for example, 27 up arrow x equals \frac 150, as I've done here, that typesets as 27 to the x equals 1/50th, as you might guess. It's the frac control sequence that we use to produce fractions. So in general, an environment will start with a begin, followed by the environment name in braces, and the environment will end with the control sequence end, followed by the environment name in braces. This is something we touched on earlier. The mathematics environment starts with the begin math and ends with an end math, but it's used so frequently that there are two abbreviations for it. Backslash left parenthesis for begin math and backslash right parenthesis for end math. Or simply $sign for begin math and $sign for end math. This is what we encountered earlier in the typeset mathematics that we saw. The display math environment, as you might suspect, starts with a begin display math, ends with an end display math, and in between you type some mathematics, which is typeset on a line by itself and centered. And there are a few other minor differences between the display math environment and the math environment. And as for the math environment, there are abbreviations for the display math environment. Backslash left square bracket for begin display math, backslash right square bracket for end display math, or simply a double $sign for begin and end display math. Here's another environment that occurred in an earlier example, the enumerate environment, which will produce a numbered list. So between the begin enumerate and the end enumerate, the control sequence item is used to begin an item in the numbered list. So for example, this source code will produce the numbered list 1, thing 1, and number 2, thing 2. This is something else we saw earlier. The center environment produces centered text. And for special symbols that we need for mathematics, or special groups of symbols, they are produced by control sequences. A control sequence is a sequence of characters or a word starting with a backslash. So here are several examples. The text BF control sequence, followed by some text in braces, produces the text typeset in boldface. The INT control sequence produces the integral sign. So this sequence of symbols produces in the output file the integral from 0 to 1 of x squared dx. You notice that I've put this sequence of symbols inside a math environment. It begins with the $sign and ends with the $sign, the shorthand symbols for begin and end math. And the reason I did that is most mathematical constructions will only work inside a math environment. If you try using the control sequence INT outside of a math environment, you will get an error message. Here are two more examples that illustrate some of the other control sequences that are pretty useful. Number one. So here again, I've put the source mathematics inside the mathematics environment. That's the beginning and ending $signs. So a backslash left brace produces a left brace in the output file. The control sequence in produces the is an element of symbol. Math BB produces the font known as Blackboard Bold. So Math BBR produces the symbol for the real numbers. The control sequence GE produces a greater than or equal to, and so on. So one thing to note is that the braces are used as punctuation in LaTeX. If you actually want to produce in your output file a left and right brace, you have to use the control sequences backslash left brace and backslash right brace. Okay, second example, I put this inside the display math environment. Right, remember that a backslash left square bracket and backslash right square bracket are shorthand for the begin and end display math. And here I have put the sequence of characters to type set a fraction. The control sequence frac is what's used to type set a fraction. Something else we saw earlier. Okay, a few words on adding space to an output document. A blank line will produce a new paragraph. This can also be done by using the control sequence PAR. If you want to insert vertical space, use the control sequence VSkip. So backslash VSkip 1.5 IN will insert 1.5 inches of vertical space. And then there's a similar control sequence for inserting horizontal space. That's about it. There are lots of websites which have a list of mathematical symbols and the control sequences that you need to produce them. I've listed one here which I've found especially good.